This lesson is on more evaluating limits in indeterminate form. So our learning goal is we're learning to consolidate our skills around evaluating limits in indeterminate form. And again, indeterminate form means that if you were in looking at A here, to let x approach 0, the denominator would approach 0, so you have to find a way to get out of the trap and be able to allow x to approach 0 to determine the answer. So for the first question, usually when you see the root signs, you would think of conjugate. So this is a conjugate. And we know from yesterday that we're going to multiply the numerator and denominator by the conjugate of the numerator. So that would be the root of 1 plus 4x minus plus the root of 1 plus x over, again, the exact same thing, so that we're really just multiplying by 1. And we've come far enough in the process that we can multiply these in our heads, so to speak. So we know that if we'll end up multiplying the first together, and that will undo the square root. That the outers and the inners will add up to 0, so I'm not going to show those. And then the last together, that's a negative times a positive is a negative, but a negative of whatever's under the square root sign. Over, so again, x, we leave it in unfactored form or undistributed form here, because that's our problematic x. So we're going to simplify in the numerator now. So we get 1 plus 4x minus 1 minus x over x times the root of 1 plus 4x plus the root of 1 plus x. So it's going to be the limit as x approaches 0 of, so our 1 minus 1 add to 0, 4x minus x gives us 3x over x times the root of 1 plus 4x plus the root of 1 plus x. So now, again, we did all that so that we could divide out that problematic x in the denominator. So now it's safe to let x approach 0. If we let x approach 0, the numerator is going to stay 3. The denominator is going to become the root of 1, because as x approaches 0, 4 times x approaches 0, plus the root of 1 again. So we end up getting 3 over 2 for the limit as x approaches 0. Okay, next one. Next one, we've got limit as x approaches a quarter. So again, we could see if we substitute in a quarter here, we're going to get the square root of a quarter as a half minus 2 times a quarter, which is a half. So we can't just substitute, as much as it would be nice to be able to do. You might think conjugate because you see the square root. But because it's only the square root of like the 1 of the x here, change a variable might be better. So we may want to let u be the root of x, so that if we square both sides, we get that u squared would be x. And then we also have to change the limit part, if you remember from yesterday. So as x approaches 1/4, u approaches the square root of 1/4, which is 1/2. So now we're ready to change the limit so that it's all in terms of u. So we have the limit as, so we want, instead of x approaches a quarter, we want u approaches a half of 1 minus, so x is u squared, 1 minus 4 u squared over root of x was u minus 2x was u squared. So now We still can't let u be a half because in that case we'd still get 0 in the denominator. So, but it's easier to factor, or we can use factoring now as our strategy. So 1 minus 4u squared is the difference of squares. Remember, it matters which term comes first. So it's 1 plus 2u times 1 minus 2u. And then in the denominator, we have a common factor of u, giving us 1 minus 2u. And in this case, it's the 1 minus 2u's that divide out. So now, is it okay to let u approach a half? The denominator would approach a half then, which is fine. So we're going to have, if we let u approach a half, 1 plus 2 times a half over a half, which is 1 plus 1, so 2 divided by a half, which is 4. So we did that one by change of variable. Next one, this big huge square root sign looks a bit intimidating, but really underneath we see we have x minus 3 and x cubed minus 27, which is a difference of cubes. So factoring a difference of cubes is probably going to be a method that we use. See, we can't approach, or we really can't let x approach 3 because the denominator approaches 0. So let's see what happens if we factor underneath the square root sign. So we get x minus 3 on the top, and then to factor that difference of cubes, it's going to be x minus 3 times x squared plus 3x plus 9. Okay, if you remember that pattern again, I have room up here to write it. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So in the x cubed minus 27 case, your a is going to be your x, and your b is going to be 3 because 3 cubed is 27. So if you were to check this, that it follows that pattern, you would see that it does. Okay, so then we want to divide out. So if we divide out the x minus 3's, you're left with a 1 on top there. So we've got the limit as x approaches 3 of the square root of 1 over x squared plus 3x plus 9. Safe to let x approach 3 now. So it's going to be the square root of 1 over, so 3 squared is 9 plus 9, so 27. And we can take the square root of 1, so we could write it as just 1 over the square root of 27. Would be our answer there. Next one, if we look at D, definitely looks like a change of variable question. Okay, so we're going to let u equal what looks complicated here, so that's 1 plus h to the 1/6. And then we want to get h by itself because we need to know it. So we would first put both sides to the power of 6, so we'd get u to the 6th equals 1 plus h, or the fact that h is u to the 6th minus 1. So then as h approaches 0, u is going to approach. So as h approaches 0, u to the 6 is going to approach 1, so u is going to approach 1. Because the 6th root of 1 is still 1. And now we can change our limit over. So we've got the limit, so we want to change h to u as u approaches 1, of 1 plus h to the 1/6, so that's u minus 1, over h, which we found was u to the 6 minus 1. So, we can use factoring now in our denominator. So u to the 6 minus 1 could be thought of as a difference of cubes again. It could be thought of, if we think about we've still got our formula up here. Go over it again. So in this case, we'd be thinking that our a was going to be u squared, because u squared to the third is u to the sixth, and our b would be 1. Okay, so going by that, we would get u squared minus 1, and then we want u squared squared, so u to the fourth plus u squared times 1, so plus u squared plus 1 squared, which is 1. But then, if you look, u squared minus 1 is still a difference of squares, so we can factor it a bit further. So u squared minus 1 is u minus 1 times u plus 1, and then still times u to the fourth plus u squared plus 1. So now finally, we can divide out the u minus 1's. And now it would be safe to let u approach 1. Denominator is not going to approach 0. So we end up getting, as u approaches 1, 1 over 1 plus 1, which is 2, times 1 squared plus 1, so that's times 3. So we end up getting 1/6 for our limit. Okay. On to the next page. All right, we see the x to the 1/6, so we're probably thinking change of variable for this one, hopefully. So if we're using change of variable, I would let u be x to the 1/6, both sides to the power of 6, so u to the 6 would be x. As x approaches 1, u approaches 1 to the 1/6, which is also 1. So now we can change it over here. So we've got the limit as u approaches 1 of u to the 6th minus 1 over x is u to, oh sorry, my bad, u minus 1, because x to the 1/6 is u, and x is u to the 6 minus 1. Okay, and again, we can do our difference of cubes with the u to the 6 minus 1. So leave our u minus 1 up top. So that's going to become u squared minus 1 if we do a difference of cubes, times u squared plus u plus, sorry, u to the fourth u to the fourth plus u squared plus 1. And then u squared minus 1 is a difference of squares still. So u squared minus 1 is going to give us u minus 1 times u plus 1 times u to the fourth plus u squared plus 1. So now we can divide out our u minus 1's, leaving us with 1. Don't forget about the numerator here. Now we can let u approach 1 in the denominator and get 1 over 1 plus 1, which is 2, times 1 plus 1 plus 1, which is 3, and we get 1/6 again. Okay, next one, like having this root in the middle here, like how would you do the conjugate? So this is another change of variable. So we're going to let u equal, we can write root x as x to the 1/2 if we want, or root x is fine. Square both sides and you get u squared is equal to x. As x approaches 9, u is going to approach the square root of 9, which is 3, because u is x to the 1/2. So 9 to the 1/2 is 3. So now we can change over our limit, so that's all in terms of u. So we're going to get limit as u approaches 3 of x, which we said was u squared, minus 4 root x, which we said was u plus 3, over root x, which is u again, minus 3. So then hopefully after we've done change of variable, it's easier to solve the limit. You can see the top looks like a simple trinomial. So a factor to give you u minus 3 times u minus 1. Negative 3 times negative 1 is positive 3. Add them and you get negative 4 over u minus 3. U minus 3 is divide out. And now we can just let u approach 3. And we get 2. So 2 change of variables we did there. And if we move up the page here, looking at G, that looks like it's going to be a change of variable as well. So we're going to let u be x plus 125 to the exponent of 1/3. And then again, if we put both sides to the power of 3, we'd get that u cubed is equal to x plus 125. Or if we want to get x by itself, subtract 125 from both sides. X is u cubed minus 125. And as x approaches 0, u is going to approach. So imagine 0 being in here, because that's u, is 0 plus 125 to the 1/3. So 125 to the 1/3 is 5, because it means the third root of 125. So now we're ready to change over our limit. So we've got the limit as u approaches 5 of u minus 5 over u cubed minus 125. So now after the change of variable, it becomes a difference of cubes question. So u minus 5 over, difference of cubes is going to be u minus 5 again, times u squared plus 5u plus 25. Our u minus 5s are going to divide out, leaving us with 1 in the numerator. Then it's safe to let u approach 5. So we're going to have 1 over 5 squared plus 5 times 5 plus 25, which is 1 over 25, 50, 75. Okay, if we look at the next one, this one looks tricky. I'm going to star this one here. You might think conjugate, but they're in the denominator. So I think we're going to start this one off anyways with a common denominator and then see what falls out of that. So our common denominator, remember, you get by multiplying the denominators together. So the denominator there is 3, and here it's root 9 plus h. So if you multiply those, you're going to get 3 root 9 plus h, and there's a minus 3 root 9 plus h. Here I had to multiply by 3, and then here I had to multiply by root 9 plus h. And that's still all over h. Okay, so then we're going to subtract the numerators in the numerator over its common denominator. And we could do the divide by h right now by multiplying by 1 over h. So we can write that 1 times that just keeps the numerator the same. In the bottom, we could have 3 times h because they're both monomials. So 3h root 9 plus h. And this is the problematic h right here, because if we try to let h approach 0, the denominator will approach 0. So now might be a good time to try multiplying top and bottom by the conjugate to free that h here. So that would be 3 plus root 9 plus h over 3 plus root 9 plus h again. So remember, we're doing this FOIL kind of in our heads in the numerator. So that's going to give us 9. And then the outer and the inner will cancel out. So, and then minus times a positive is a negative. The root goes away, but we're subtracting the whole part that was underneath the square root sign. And then the denominator is just going to be really nasty here. So 3h root 9 plus h times 3 plus root 9 plus h. But we're still hoping that this problematic h right here is going to be able to be divided out. So limit as h approaches 0. So 9 minus 9, that's fine. That's going to give me 0. But remember, it's distributed. So that's going to give me a negative h on top. A lot of people make a mistake in that part right there. They'll have just a positive h there, and they'll get the wrong answer. So be careful. Over 3h root 9 plus h times 3 plus root 9 plus h. So now finally these h's will divide out and we'll be left with negative 1 on top. So it's safe to let h approach 0. When we do that, we're going to get negative 1 over 3 times the root of 9, which is also 3, times 3 plus the root of 9, which is 3 again, which is going to end up giving us negative 1 over that 6 times 3 is 18 times 3, or 9 times 6, which is 54. So after all that, we get that the limit is negative 1 over 54. Next one. Okay, so this one looks tricky. I'm going to say we're going to do a change of variable here. So we can either try letting u be x to the 1/6 or letting u be x to the 1/3 and then see which one works out better. So we'll start with trying with the smaller one first. So let u equal x to the 1/6. So that means if we put both sides to the power of 6, u to the 6 would be x. So if that's the case, what would x to the 1/3 be? That would involve, so whatever we do to one side, we do to the other. So putting this u to the 6 to the 1/3. And why do we need to know x to the 1/3? That's another way of writing the third root of x. So this does work out nicely because then we've got that x to the 1/3 is u to the 6 times 1/3. Power of a power, you multiply exponents. So you end up getting u squared, which is nice. And then also as x approaches 64, u is going to approach, so if we put a 64 up here, 64 to the 1/6 is 2, so u would be approaching 2. So now we can change the limit over. So we go from limit as x approaches 64 to the limit as u approaches 2. The 6th root of x is our u, minus 2. Third root of x we figured out was u squared, minus 4. So the change of variable was a little bit trickier because we had the 6th root and the 3rd root there to figure out. So letting the smaller exponent be u was the correct thing to do, or the easier thing to do, let's say. And then the bottom becomes a difference of squares. And then our u minus 2's divide out. Then it's safe to let u approach 2. So we have 1 over 4. Nice. Okay, so that one was a tricky one. Maybe go over that one again. I think there's one like that in the practice for today. And then our last one. Okay, so this one, we can't let x approach 1 because we have this x minus 1 here. Sometimes when you look at these and you say, well, I don't know what to do, sometimes you just start off by doing what you can do. So I see that I can subtract these fractions here, so I'm going to start off by doing that. So that's going to give me 1 over x minus 1. And then here to subtract, we need a common denominator. So my common denominator is going to be x plus 3 times 3x plus 5, and minus x plus 3 times 3x plus 5. So really we're doing this, we're subtracting the fractions just because there didn't seem to be anything else to do there. We could have distributed it, but that didn't look like it would be very nice. So here I had to multiply the denominator by 3x plus 5, so I do that to the numerator. And here I had to multiply the denominator by x plus 3. So I guess what we're hoping for is that we'd end up with an x minus 1 on top to divide out this problematic x minus 1 here that would approach 0 as x approached 1. So now we're going to do the step where we subtract, in this case, the numerators over that common denominator that we found. Simplify the numerator some more by expanding. So it's going to give me 3x plus 5 minus 2x minus 6 over x plus 3 times 3x plus 5, which is the limit as x approaches 1 of 1 over x minus 1. So that's going to give me 3x minus 2x is x minus 1 over x plus 3 times 3x plus 5. So now these, maybe I'll just add another step in. So in the numerator, I've really got this 1 multiplying by x minus 1. And in the denominator, I've really got these 3 binomials all multiplying together. So these x minus 1's divide out, leaving me with 1 in the numerator. Now it's safe to let x approach 1. So I end up with 1 over 4 times 8, which is 1 over 32. All right, and that is the end of our lesson on solving more limits.